We put a lot of faith in our systems. We believe that the critical infrastructure we rely on every day, in tech, finance, you name it, is built from the ground up for safety and stability. The whole point, we think, is to prevent some kind of catastrophic failure.
But what if that whole idea is just wrong?
What if systems aren't designed to prevent failure, but to actually produce it? Not by accident, but by their very nature. To get our heads around that, we have to look for a hidden pattern, one that plays out over and over again.
It always starts with something small, a slow, creeping threat that's almost invisible. It doesn't scream emergency, it's just background noise, a tiny little deviation from the norm.
And because the system is busy doing its main job, it does the rational thing. It ignores it, right? It's not an immediate priority, it doesn't match any of the error codes it's looking for, so it just gets filtered out.
And then, seemingly out of nowhere, the whole thing shatters. The stable, dependable system just collapses. It feels sudden, but the truth is, a hidden structural force has been pushing it towards this exact moment the entire time.
Okay, to see this force in action, let's just picture a simple physical system, a dam. You've got the clear reservoir behind it and a spillway built to handle any extra water. Everything looks stable. Everything looks like it's in perfect balance. And that's the thing about complex systems. At their core, they really are designed for stability. They have these powerful automatic reflexes that are constantly working to keep things in a target state, correcting for any little bumps along the way.
This self-correction mechanism is literally everywhere. It's the thermostat in your house, kicking on the heat when the temperature drops. It's the cruise control in your car, tweaking the engine to keep you at a steady speed. It senses a deviation and it fixes it. It's simple, constant, and incredibly effective.
But, and this is the crucial part, this creates a massive trade-off. To be so good at fixing the problems it knows, the system has to be laser-focused on what it can measure. It gets optimized for these short-term targets. And by doing that, it becomes structurally blind to anything new, anything slow-moving, anything it isn't already measuring.
So let's be really clear about this. The system's greatest strength, its amazing efficiency at solving the problems it can see, is the very thing that creates its most devastating weakness. Its efficiency creates its ignorance.
So, let's go back to that dam. While the system is brilliantly managing the water level, the one thing it's designed to measure, something else is going on underneath. Silt, just tiny particles in the river, starts to build up on the bottom of the reservoir. It's a slow, quiet change that nobody is watching.
And that right there, that is exactly how risk builds up in complex systems. It doesn't show up with a flashing red light. It just accumulates quietly, right below a surface that looks perfectly stable, growing in the areas that no one thought to monitor. All of this accumulated, unseen risk creates a condition we call brittleness. It means the system has lost its cushion, its resilience. It can't absorb a shock anymore, even one it could have easily handled in the past.
For example, think about a hyper-optimized supply chain, one with zero extra inventory. It's incredibly efficient, right? But now, one small delay with a single part doesn't just cause a slowdown, it brings the entire production line to a grinding halt. That system has become brittle.
Back at our dam, that layer of silt just keeps getting thicker. Now from the surface, the reservoir looks just as full as ever. But its real capacity, its ability to handle a sudden rush of rainwater, is secretly shrinking. The dam is now incredibly fragile, even though it looks exactly the same.
And then the shock comes. And we're not talking about some historic 1,000-year flood. It's just a normal, heavy rainstorm. Exactly the kind of shock the system was originally built to manage without a problem.
But the system isn't what it used to be. The shock hits that brittle structure. The water has nowhere to go because of the silt, the spillway is overwhelmed, and the dam fails. The stable system collapses.
So, what was this hidden force? This mechanism actually has a name. It's called negative feedback. And yep, it's the very same self-correcting impulse that kept the water level, the thermostat, and the car's speed so perfectly stable. But here's the paradox. Negative feedback is also the mechanism of self-blindness. The exact same process that creates stability by narrowing its focus is the process that creates fragility by ignoring everything else. The stabilizer is also the destroyer. That's the conflict at the heart of the system.
And that's why the crisis itself isn't the real failure. The collapse, that's a forced revelation. It is the one moment when the system is finally forced to see the risk it was blind to. It's forced to see the silt.
And after a revelation like that, there is no going back. You can't just flip a switch and return to normal. The old system, the one that was built on a foundation of ignorance, is gone for good.
This learning process follows a predictable path. First, the crisis. That leads to the revelation. The revelation creates a new rule, something like, from now on, we have to measure silt levels. And that new rule forces a new, permanent structure. This is how systems actually learn, not from gentle warnings. They learn from collapse.
So, our dam gets rebuilt, but it's not the same dam. Maybe now it has a much larger spillway, or maybe there's a permanent dredging program in place. It now carries the physical scar of its failure, a structural change that finally acknowledges the risk it used to ignore.
And this brings us to the final, really jarring realization. The system was never malfunctioning. The collapse wasn't an error. The whole time, the system was just following its own rules. It was perfectly executing a logic where an obsession with short-term stability guaranteed its own long-term destruction. The breakdown wasn't a deviation from the plan, it was the plan.